My name is Greg O'Corry-Crowe and I am a research professor at Harbour Branch Oceanographic Institute, which is at Florida Atlantic University. So I grew up in Ireland and I grew up in the countryside and was always very interested in nature and wildlife in particular. And so I did my studies in zoology. I was very interested in animal behavior, and I through that got really interested in genetics because I felt genetics answered all those questions that were hidden from a behavioral scientist. And I've made a career of putting those two very powerful kind of techniques together. And so when I came to the United States, I got an opportunity to work on marine mammals, which was very exciting. But what made it even more exciting was I got to work in the Arctic with indigenous communities on beluga whales. And I feel I kind of found my home up there. We've got 2 ears and just one mouth, so we should listen more than we talk. So getting the opportunity to go to a place that I knew nothing about and knew that I was definitely out of my element, I was very keen to learn. And out of working with indigenous peoples across the Arctic, I think it really has changed a lot about how I approach my work. We have a pretty broad interest in questions, but they're very much driven by emerging environmental and sort of endangered species problems. So there's sort of a time crunch element to what we do. And a lot of that has to do with, for example, identifying separate populations, using genetic markers as indicators of gene flow and dispersal and isolation. But more and more now we're trying to get into the nitty-gritty of why maybe some species are struggling and others are not, why some populations are not recovering following some kind of protection and others are. Obviously, a good place to start is sort of at the molecular level. And one of the issues in conservation now is everything seems to be breaking and it's almost a hopeless case. And hopelessness leads to paralysis. But what's actually going on is these systems are incredibly resilient. And so we're just trying to get to the molecular underpinnings of some of those kind of elements of resilience and adaptability. And genetics, I think, is a keystone to all of that. So a major role where Applied Biosystem Technologies are helping us is some of their platforms are essentially the workhorse for funneling a lot of these challenges and questions through. And so, for example, a lot of our work is still very much focused on conventional electrophoresis, whether it's Sanger sequencing or whether we're looking at STRs to reconstruct pedigrees, understand patterns of adaptation and diversity. That's still crucial to a lot of what we do. I mean, I think another really valuable role that Applied Biosystems Technologies can play is working in partnership to solve some of these technological problems and making things more accessible. So not just in terms of various platforms being available, but how do you solve problems with chemistries and with the consumable kits and things like that. And so that has been really rewarding because we're always running into challenges. We tend to use up all our resources, suffering in silence, trying to fix something when we now can, through this new sort of relationship, have a team of people saying, oh, listen, we can help you there. And that allows us then get on with what the ultimate goal is, which is, solving some of these big problems.